Thank you very much for your kind introduction. I also want to welcome you to my presentation of the joint project of KS Engineers and IPG Automotive to implement route switching options in CarMaker. Today, I want first to give you an idea why we started this project and how we approached an initial solution. Then I will give you an example, starting with how to set up such a simulation, and then show you the outcome of such a simulation. And then I will give you some more insight at the end to the functions that we have implemented, and of course to the limitations that we have, and make some conclusions. So, why did we start this project? As you all know, the drivers of electric cars expect some special functions for convenient use. I will focus here on two of these functions. This is the range estimation and the charging strategy. The first function you probably all know from a conventional car, but in an electric car, this has to be much more precise due to the normally smaller range of an electric car and the higher dependency of the range on the environmental conditions, especially on the temperature outside. The second function is a specific function that is of interest for long-range drives in which you need intermediate recharging processes. Here, the recharging is typically longer than a refueling of a conventional car, and the time is dependent on the status of the battery as well as the capacity of the charging stations that you are at. This means that an optimal route planning takes this into consideration and adjusts the number and kind of charging stops that you have during your drive, depending on the traffic conditions and the estimated power consumption that you will need for the rest of your drive. If you want to test such a function, you need to apply very realistic road conditions. This means not only that you have to reproduce the topology and the speed limit, but also the temperature conditions on the road. Furthermore, you should have realistic charging characteristics of the charging point that you're using during this test. Of course, you can say, let's define a route where you drive on and do this over and over again, but then you don't get repeatable results. Furthermore, the temperature you can't influence on a real drive, so you have long times between similar test executions, so you better look for a specialized test rig that enables really repeatable tests. We found such a test rig at IPG, and not at IPG, at KS Engineers, and with a functional integration test rig. This test rig enables us to apply realistic road loads that are derived from the topology during a simulation. It is also possible to apply GPS spoofing so that we can inject the location of the car on the geolocated map in the simulation to the navigational system so that it makes the right suggestion for new routes. We also can inject other sensor information, such as acceleration sensors, and for other functions, if needed, also, for instance, video data. In this setup, we also have climate control that allows for the study of the influence of the temperature. And there is a charging point available that emulates different charging characteristics. So CarMaker here is the simulation heart of this test rig, providing the data to apply the road loads and the raw data for the sensor stimulation. So taking all this into consideration, this looks like a pretty good candidate for such a test rig we are looking for. Consequently, we did a first evaluation test. And with the first function, we did very well. We could really good reproduce effects that we saw in real measurements, even reproducing the temperature and the topology influences on certain results. However, we had a problem to test the second function. What was the problem? Well, as described before, the multi-step route planning adjusts the number of charging points during the simulation. This means that the initially planned route will change during the simulation depending on your traffic conditions and, well, of course, on the temperatures that you are experiencing. In contrast, CarMaker needs a static route throughout the whole simulation. So what can you do? Well, of course, you can stop the simulation when you need a route change. This means also you have to stop the test rig with the car on it. You have then to exchange the route, place the car in the simulation at the exact same position, and restart the test. Well, that's not very realistic test conditions. Therefore, we were looking for a different solution. And thus we took a step back and tried to define what is really necessary to test this kind of function. So, of course, you have to define a main route that you want to test. Okay, that's fine. We have this already. In the vicinity of this route, you will have a number of charging points. Not all charging points in the whole region, but only a number that are of interest. And you have then to be able to define routes that are leading from your main route that you want to drive to these charging points and back in a similar way like your navigational system would suggest. During the test, the operator should then be able to select these routes and switch to them in an easy way. For CarMaker, this means that it has to support the user in the selection of these routes, and once the user has ordered such a route change, it should enter this new route automatically without any further interaction of the user once this route becomes available. Once the car is on the route, it should be controlled in a similar way like on the main route, and it should come to a halt at the charging station. There, we do the recharging process, and afterwards, we should be able to start the drive again without shutting down the whole simulation in between. The car should then also return automatically to the main route. In CarMaker, this means that we need add-ons to the both main building blocks, the back and the front end. And in the back end, we have to connect to the standard libraries of CarMaker in order, for instance, to use the IPG driver. And for this implementation, we choose the option to use the user-accessible modules. And there, we entered the new library. This provides the connection to the backend function, for instance, of the IPG driver, and brings in some new functions, for instance, like the route selection and the control during the transition. Since the user should be able to operate with this function from the GUI, we have also there an add-on that enables us to start this function, select the route, and also get some status information. Of course, these two blocks have to interact with each other. If you want to set up such a simulation, you just start in the normal way by defining your main route, or routes if you need several. Then you mark the ways to the charging points. What you have to do there is quite simple. You start on the main route with an overlap. Then mark all the way to the charging point with the same functionality like for defining a main route, and back to the main route again, allowing for an overlap again. At the charging point, you just place a stop marker to indicate where this is located. That's all you have to do. With this preparation done, you can start your simulation. And first of all, you open up the new window, and you can activate the function. Once the simulation is running, you will get an information in the lower part of the window of the available alternative routes with their location on the route and the route IDs. Now you have the option to enter this route ID to choose a certain route for your exit, or just use the next exit button to, for brevity, to use the next available exit. If you made a mistake, you can correct this as long as you have not entered the alternative route. Once you're on the route, the car proceeds to the charging point. You do the recharging, and after this, you just hit the charging completed button, and you will continue your journey to, back to the main route again. If you are on the alternative route and you want to skip the charging point, you hit the cancel button, and then the car proceeds using the alternative route just back to the main route again. So, oops. Now I will give you an example of such a simulation. In the upper in both cases, the same main route is defined. So basically, if we would do nothing, both would look like the same simulation. In the upper simulation, we will use the out next exit button to use the first available exit for a charging stop. In the lower one, we will enter the route ID to use the second stop. So you can observe the inputs done during the simulation on the right-hand side. And so let's start the simulation. You can see that in the upper one, the out next exit button is hit, and in the lower one, the exit number for route number 5 is chosen. Then we are approaching the first available exit, and as you can see, the upper car leaves the main route. The lower car will proceed its drive on the main route. The upper car is now on its way to the charging point, which is a little bit further away. It will approach the charging point, will come there to a halt to allow the recharging to be started. And it will stay there until the recharging has been finished. There's a charging point, and it will come to a complete halt. The lower one has also left the main route, entering route number 5 to the second available exit. You see, we have speed up the charging process just a little bit, and are now returning to the main route. The lower one has also finished the charging process and is also heading for the main route. Once the car is back on the main route, you can start the game over again with the next available exit, or even with one which is 80 kilometers away if you need this. So, okay. So as you have seen in this example, we are now able to switch from the main route to an alternative route during a running simulation. In order to make this operational on a test rig, we had to add some additional functions to make it safe for the operator to do so. The first function, of course, is to find the available routes for the chosen main route. So we provide then a list with all the routes that are fitting to the main route that you have selected previously. Then we also check these routes if they are really complete, if they are really terminating on the main route again, for instance. If this is not the case, this route will not be listed, and you will get an error message in the execution showing that you have there a route that would be possible to use, but it has some error in it. We also suppress the accidental change to an alternative route once you left the main route, because this would lead to excessive driving signals you don't want to have on a test rig. Since we are focused on the main functionality, we are aware that there are certain limitations of this implementation. One of this is that we cannot cancel a route immediately and return to the main route as a human driver would do. We have to follow the prescribed route. The other one is that on the alternative route, no traffic can be applied. Well, this has to be overcome in future development steps. Since we used a regular stop marker for indicating the location of the charging point, we cannot distinguish between such a stop marker and a stop marker at an intersection. That's also a problem. And the minor problem is that in the overlay for the route preview, you will not see these alternative routes. To sum it up, I've shown you today a new functionality in CarMaker that enables you to switch to a different route during a running simulation. For us, this is an enabler to test functions like the multi-stop route planning on the functional integration test rig. IPG is going to implement this base functionality in the back end in the CarMaker 14 version, making it part of the standard product. Thank you very much for your interest, and if you have questions.